We are now going to be talking about the Global Positioning System, or a GPS system. What I have here is a base unit. The base unit has been mounted to a tri-bract brace, similar to the tri-bract brace we had in both the total station and the auto level. The tri-bract brace is mounted to the tripod, and similar to the all of the other equipment, it has an optical plumb in which we can set up directly over a point. We would also use the leveling screws to make sure that we level the instrument, making sure that it is level and directly over the point in which we have the known data. The base unit's function is to record readings from satellites that are within our spectrum. The satellites will then be downloaded into the total station, and it will compute a location of the point on the satellite and the GPS receiver itself. That location then, we will, by measuring the height difference from the ground to the instrument, we will then be able to determine the position of the point on the ground. That signal then will be sent out, and the base unit will use a radio device mounted internally in which the signal will be sent out to roving units within the area. And now I'd like to introduce you to the communication between the base unit and the data collection. One of the things that we would initially need to do was set up the job. I have already set up the job so that we can start from this screen right here. One of the things I'm going to do right now is set up the initial configuration. What I want to do is start a communication dialogue between the instrument itself and the data collection instrument. So I will go over here into the configuration screen, and we will configure the screen for the survey applications. The series of questions will be asked. For example, that's asking us the unit itself, so it recognizes the type of unit. I will accept the defaults here. This will be subject to your manufacturer. Now I have went into a screen where the screen now is going to look at the Bluetooth signals that are being sent out there. So what I'm going to do is I'm going to ask it to find the GPS unit. Since this is a base unit, I am going to ask it to find the base unit that was previously stored in there, and I'm going to ask it. It is now going to be searching and searching until it finds the base unit. You will notice up here on the unit itself, the manufacturer will have, of whichever equipment you use, will have a sequence in which it explains the light sequence and understanding that. Right now I will find out, and by looking here, I have found out that we have found the base unit. The instrument has recognized that the base unit is there, but I have not told the base unit to go ahead and connect to that. So what I am going to do is go ahead and choose that and say select, and I will wait for a communication. There was a slight sound that you may have heard here in which we found the communication has recognized and the Bluetooth technology has recognized. Now we have communication between the base unit and the data collector. What we want to do now is set up the base unit. So we will go into the initial setup screen. We're going to set up the base unit. And by looking at the base unit, I come up with a series of screens. Now, one of the things that would normally happen, and in our environment today, I'm not going to be able to demonstrate this, but we would have two options. We could either know the location of the point we're observing or setting up over, or we could not know the location of that and ask the GPS system to find it for us. Either system is usable and very common in today's practice. If you do know the location of the point, then you would have it pre-stored into your data collector, or you would type it in at the time. And then by giving the GPS software the difference in height between the point on the ground and this arrowed point right here on the GPS unit, it would then be able to take that data and do a correction factor and be able to broadcast the location of this base unit to anyone who's out there using and able to collect that. So that's what you were hearing. You may hear this, the GPS telling us, oh, that's a screen that many of these units have audible alarms that will allow us to the luxury of knowing whether or not it's observing the satellite imagery. And since I'm doing this series inside a building, we're not able to connect to GPS, the satellites right now, so therefore we're going to hear some audible alarms informing us that we are unable to connect. Once we've set up our base unit, either by having it find itself or setting it up there, and once we've put in the height, then what we would do is tell the base unit to go ahead and start. And by most units, we'll have some sort of system to start the base. Once we start the base will go into the communication port, which means it will then start sending the location of its signal, the signal location of its point right here, out to all other roving units within the area. So our next step would be to set up the roving unit. Once we've set up the base unit, we're now ready to set up the communication port between the base and the rover unit. Now remember, the function of the base unit is to broadcast its signal with its location to any of the units within its range. When I use the word range, I want to inform you of basically how the GPS units operate. The GPS units will control three types of basically technology in here. One technology being the battery that that functions, that cause the instrument to operate. Another of the functions within this is the GPS capability itself. And the third one is the radio capability. There's an onboard radio built inside this in which it's sending a signal out. Now, depending on the manufacturer and the type of instrument, there'll be different ranges for your radio signal. This particular radio signal has approximately about 1/4 of a mile that could be sent out here. So we can communicate with any kind of a roving unit within the 1/4 of a mile range of the unit. The next unit right here that you see to my right here is the roving unit. You'll notice that the roving head looks similar to our base unit, and they are very similar in their use and operation, and actually in their ability. The difference is that the base unit is using the radio frequency to broadcast out the signal. In the roving unit, we're not broadcasting a signal. What we're doing is we're receiving signals. So it looks for that. So in the situation of the roving unit, we would turn it on, have our light sequence similar to that of the base unit, and making sure that the sequence is in compliance with the manufacturer's specifications, and each of the lights indicating whether or not it's properly receiving satellite communication. The next thing we would do is we would take our data collector. The same data collector that we used when we would set up the base unit. The difference is now is once we've set the base unit up, it's not necessary to keep communicating with the base unit because the base unit's signal is being sent to the roving unit. So now what we're going to be concerned about is communicating with the roving unit. So I'm moving the data collector now over to the roving unit, and what I'm going to do is get out of this screen, and actually I would back to the communication port and go back to the configuration screen. Go back to the configuration screen again and tell it to the type of instrument. Again, it's asking me what type of instrument this will be. And then I would get a communication port, and what it's going to do now is tell me it's looking for a rover unit. So if you know the rover unit, normally the rover unit indicators are given in the serial number, and that's what's broadcast out as the signal. So if I could find the serial number that communicates with the point on the data collector, I would then be able to accept the roving unit, and I would select the roving unit, wait for communication. Once we establish communication, there's communication. Now that communication is established, we have Bluetooth communication between the data collector and the roving unit. What we would now do from this stage is we would set up the instrument so that the instrument now can be communicating. The GPS technology works because the instrument, the base unit knows where it's at. It's sending that signal to the roving unit. The roving unit, through a series of computations and using the same satellite technology, the same satellite coverage, can determine where it's at, and it will then apply a correction factor that's been given from the base unit, and the two units now are communicating. So we can get sub-centimeter accuracy between the two units. Some key things to remember when using the roving unit is that the rover has to have been programmed in the height between the roving unit and the ground, and it has to have also been programmed in it the same database system that you were with in the base unit. That's all controlled through the data collector. This technology is called RTK, or what we call real-time kinematic. The real-time kinematic allows us to have real-time data as accurate as the base unit is delivering it. We can have it on any roving unit that's within the communication realm of the base unit.